Here we'll do an example of a system of three equations that has no solution. The first thing we'll do with this system, as with our previous video, is we will look for a single letter to solve for in the system. Once we've located that single letter, we will replace all occurrences of that letter in our system. If we examine our system, we will see that in line 3 of the system we have a single z. Therefore, we will solve for z in line 3 first, and then once we've done that, replace all the z's in the system. If we begin on line 3 with negative 3y plus z equals negative 10, we can add 3y to both sides, taking this negative 3y and moving it to the other side. The negative will become positive when you move it, and so we'll have 3y on the right, positive rather than negative. This will leave us with z equals negative 10 plus 3y. Now the only occurrences of z in the system are here in line 1 with this other z I'm circling. So we will make a new line 1 now where we replace that z. Previously we had 4x minus 4y plus 2z equals negative 14. However, we're going to replace that z now with the negative 10 plus 3y and place it where the z previously was. Now that we've made the replacement, we can simplify our line 1. Remember that our goal now is to get all of our letters on the left and our constants on the right. Therefore, we will take this 2 times the negative 10 and 2 times the 3y, and we will distribute. If we do so, we will end up with 4x minus 4y minus 20 plus 6y equals negative 14. Since we have a constant of negative 20 on the left, we will need to move that to the right. When we move it, it will become positive, and on the right we will have negative 14 plus 20, giving us positive 6. The left will still have 4x minus 4y plus 6y. Then we can combine the y terms, negative 4y and positive 6y. When we do so, this will give us 2y, along with the 4x equals 6. This will be our new line 1. On the next page, I will copy that new line 1 along with our line 2, which we have not touched yet. On this next page, we now put our new line 1 with our old line 2, which we didn't have to change. Now we can try to solve this system of only 2 equations. Since we don't have any single letters anywhere in the equations, we'll try to use elimination method. You may notice that the x terms, 4x in line 1 and 4x in line 2, are exactly the same. When you have x terms that are exactly the same, we can now just take line 1 minus line 2. This is true anytime you have any variable term that is exactly the same. To put this another way, we can just multiply either one of the lines by negative 1. I'm going to choose line 2 for this, but in reality it doesn't make much difference which one you do. So line 1 stays the same, but in line 2 we will distribute this negative 1 to all 3 of these terms. Line 1 will still be 4x plus 2y equals 6, and line 2 will now be negative 4x minus 2y equals negative 14. Now, when we combine these terms, we can see that 4x and negative 4x will cancel, and 2y and negative 2y will cancel. This leaves us with 0 on the left and 6 minus 14 for negative 8 on the right. Notice that now we have a false statement. 0 does not equal negative 8. If you try to solve a system of equations but you end up with a false statement, what that means is that the system doesn't have a solution. Systems that don't have a solution are also sometimes called inconsistent. For this class, if you get an inconsistent system, all you'll need to write for your solution is DNE or does not exist. So this was completely different from our last system solution because last time we solved this in part 1, we got that z equals some number. Now we have a number equaling a number that's clearly not the same, therefore you have a false statement and the solution does not exist.